Bismillahirrahmanirrahim. This is the second part of the topic course content alkene. Okay, so I'm starting from arenes. So in the previous lecture, I told a little bit about the alkenes. So arenes. So arenes, they are the third class of unsaturated hydrocarbons, and the Lewis structure of alkene is written like this. Look at this is the cyclic structure, 6 carbons, okay, and there is a dotted line, one dotted line, which means that there are 3 double bonds which are delocalized. They are not static to one position, but they are moving, okay, so they are delocalized. They are not localized bonds. Next explanation, we'll go to the slide number, this is slide number 21. Okay, so these are the 3 different pictures which are given for benzene. The molecular formula of benzene is C6H6. Okay, this is the expanded structure, this is the line structure, and here you can see that there are 3 double bonds, but here an inside circle is given. So this inside circle is known as, so this inside structure is actually showing you the delocalization of the pi system. Pi system means that pi bonds, okay? Jitne bhi pi bonds hain. So there are 3 double bonds, 1, 2, 3. So there are 3 pi systems over here, and this circle actually, this indicates that these all the electrons of the pi system, they are delocalized. They are not localized. Okay. So next we move to slide number 22. So 22 slide is explaining you. It is telling you about something which is very similar to alkyl groups. You know that the letter, for example, this is CH4. If you remove one hydrogen from CH4, it will become dash CH3. It will become dash CH3. Okay. So now this is called, it is not methane now, it is called methyl group. Okay, it is called methyl group. So अगर हम next में आ जाएं, for example, dash CH3, okay, and again CH3. This is ethane, okay. And when we remove one hydrogen from ethane, it will become CH3CH2. Okay, so this is called ethyl group. So collectively, these are known as alkyl. Similarly, we apply this thing to the hydrocarbons, aromatic hydrocarbons. Jisme benzene is the basic structure, C6H6. Now it is saying that a group derived by removal of an hydrogen from an arene is called an aryl group, and it is given the symbol AR. Okay, so C6H6 में से if you remove one hydrogen, you will get AR, C6H5AR. Now this aryl group substituent on a parent chain is a benzene ring. It is given the special name phenyl group. अब ये अगर aryl group आपका किसी भी benzene ring के ऊपर अगर it is added as a substituent, so हम इसको, when we write the name, we write it phenyl group. So aryl group, AR, abbreviation is AR, a group which is derived from an arene by removal of an hydrogen. So phenyl, what is then phenyl? Phenyl group A, it is a group which is derived by removing an hydrogen from the benzene ring. C6H5, or it is abbreviated as PH. So these things you need to understand very carefully. Our next heading is the index of hydrogen deficiency. Now, index of hydrogen deficiency means that we are locating the double bonds and triple bonds. So you know that the general formula for alkane is CnH2n plus 2. But for alkenes, the general formula is CnH2n. And for alkynes, this is CnH2n minus 2. So if you are writing according to my, as I'm speaking, and if you are writing these things, so you will see that in CnH2n plus 2, for example, if I add the value of Cn as C6 और H जो हो जाएगा वो 2 into 6 हो जाएगा plus 2, तो ये हो जाएगा कि C6 जो है उसमें total hydrogens जो हैं they are 14. Okay, so alkenes की तरफ अब अगर आ जाते हैं आप, वैल्यू आप C की लगाते हैं C6 और उसमें अगर एक डबल बॉन्ड है आपका, एल्कीन्स में आ जाते हैं, हेक्सीन की बात आप करते हैं, तो आपके जो हाइड्रोजन्स होंगी वो टोटल 12 होंगी. ओके, 12. और अगर आप एल्कीन इसी में ही आ जाते हैं, आप फॉर एग्जांपल पेंटाइन पे आ जाते हैं, ट्रिपल बॉन्ड्स की तरफ आ जाते हैं, तो उसका फॉर्मूला होगा C6H10. ओके, सो ये मैंने जो कैलकुलेट किए हैं नंबर ऑफ हाइड्रोजन्स बाय यूजिंग द फॉर्मूला CnH2n plus 2 for alkanes, CnH2n for alkenes, and CnH2n minus 2 for alkynes. So this is how. Now, index of hydrogen deficiency means that we need to understand that how many hydrogens are less than the normal number. So if there is an indication of hydrogen deficiency, it means that there must be either double bond, triple bond, or there must be cyclic structures. So तो हम कहते हैं कि index of hydrogen deficiency is the sum of the number of rings and pi bonds in the molecule. जितने भी rings हैं या pi bonds हैं उनको हम together sum up करते हैं so that we can give you the index of hydrogen deficiency. So in a hydrogen, in a hydrocarbon, where all the carbon atoms have one single bond, there is no rings are involved, the compound would have the maximum number of hydrogen atoms. As I have told you, if you go for the hexane, तो hexane में आता है C6H14 molecular formula. अगर आपका जो, if any of the bonds are replaced with double or triple bonds, if any of the bonds are replaced with double and triple bonds, or if rings are involved, there would be a deficiency of hydrogen atoms. So we need to understand that how we calculate them and what is meant by hydrogen deficiency. A double bond and the ring each counts as one index of hydrogen deficiency. अगर आपके किसी भी, if there is a structure for example and if there is one double bond, so हम इसको कहेंगे कि इसकी index of hydrogen deficiency is equal to 1. अगर cyclic structure है फिर भी हम कहेंगे, क्योंकि cyclic structure में जब structure आता है तो loss of 2 hydrogen होती हैं, तो साइक्लिक स्ट्रक्चर में भी लॉस ऑफ 2 है और वन डबल बॉन्ड में भी लॉस ऑफ 2 है, तो हम कहते हैं कि डबल बॉन्ड या रिंग जो है वो प्रेजेंट है, तो अगर इट मींस द इंडेक्स ऑफ हाइड्रोजन डेफिशिएंसी इज 1. ट्रिपल बॉन्ड की जो काउंट्स हैं उसमें इंडेक्स ऑफ हाइड्रोजन डेफिशिएंसी जो है वो 2 है. ओके, अच्छा, अब हमारे पास एक फॉर्मूला है. सो आई हैव रिटन दिस फॉर्मूला 2n + 2 - h डिवाइडेड बाय 2. अब आपने रिमेंबर करना है, क्योंकि हम whenever we are talking about the carbon hydrocarbons, okay, so we obviously know this thing, and it is I mean in general we think about carbon and hydrogen, so no need to write carbon or hydrogen because it's understood that this is about the carbon and hydrogen. But when the heteroatoms are present, for example nitrogen and phosphorus, both of them belong to the same group. If nitrogen and phosphorus हो तो हम जब हाइड्रोजन इंडेक्स ऑफ हाइड्रोजन डेफिशिएंसी को कैलकुलेट करते हैं तो -1 करते हैं. अगर नाइट्रोजन है तो -1 हाइड्रोजन करेंगे. इफ फॉस्फोरस इज देयर तो फिर अगेन वी गो फॉर द -1 हाइड्रोजन. अगर ऑक्सीजन एंड सल्फर आर heteroatoms in the structure, so there will be no plus and minus. But if fluorine and chlorine are present as the heteroatoms, we add one hydrogen to the already present hydrogens. Now it is difficult for me to calculate on the board, so I have pasted here I have copied a link, and this is the link. Follow the link and you will understand. इसमें जो आपकी एग्जांपल्स दी गई हैं अबाउट 3-4 स्ट्रक्चर्स उन्होंने एक्सप्लेन किए हैं कि हाउ टू कैलकुलेट इंडेक्स ऑफ हाइड्रोजन, और बहुत डिटेल में दे हैव गिवन यू सो दैट यू कैन अंडरस्टैंड वेरी क्लियरली. नेक्स्ट वी गो टू द सिस ट्रांस आइसोमेरिज्म इन एल्कीन्स. आपको पता है कि व्हाट आर द आइसोमर्स? Molecular formula same but different connectivity. But now we need to understand the isomerism in alkenes. So in alkenes, the isomerism is called geometrical isomers. So isomerism that have the same order of attachment of their atoms but different arrangement of their atoms in space, owing to the presence of either a ring or a carbon-carbon double bond. So this is, we have some different types of isomers. Since we know that the rotation around the double bond is highly restricted, so carbon-carbon double bond rotation is very restricted. It is not as free as in the alkanes. So any alkene in which carbon of the double bond has two different groups bonded to it shows either cis isomerism or trans isomerism. Now, for example, 2-butene has two stereoisomers. Number one is the cis-2-butene, and with the two methyl groups on the same side of the double bond, and two hydrogens on the other side of the double bond. So in trans 2-butene, two methyl groups are on the opposite side of the double bond, and these two compounds cannot be converted into one another at room temperature because of the restricted rotation about the double bond. So they are different compounds, so they are known as stereomers with entirely different physical and chemical properties. Now this is the picture of two methyl groups are on the same side of the double bond and two hydrogens on the same side of the double bond. So this isomer has the configuration of cis. Here we can see that two methyl groups are opposite sides of the double bond and two hydrogens are also on the opposite sides of the double bond. So this is the trans 2-butene. Cis alkenes with double bonds in upper chains are very less stable than their trans isomer because of steric strain between alkyl substituents on the same sides. Now again I'll go to this. यहाँ पे steric strain ज़्यादा है क्योंकि heavy group जो है methyl groups they are very close to one another. तो यहाँ पर थोड़ा सा strain जो है वो less है. Now we come to the slide number 32 in which the E and Z system जो है इसको explain किया जा रहा है. हमें पता है कि cis और trans system जो is there, but sometimes cis and trans system becomes confusing with tri and tetra substituted alkenes and is not detailed enough to name all alkenes. So chemists developed another naming system which is known as EZ system. Now this system uses the plurality rules of the R and S. जब आप stereochemistry, when you go for the stereochemistry, तो वहाँ पर हम RS system को use करते हैं to assign the priority to the substituents on each carbon of a double bond. So it depends on the atomic numbers, okay? So is right now it's not the course content, so I'm not going to discuss in detail over here. So using these rules, we decide which group on each carbon has the higher priority. If the groups of the higher priority are on the same side of the double bond, the configuration of the alkene is Z, German Zeusa, Zoosamen means together. If they are on opposite sides of the double bond, the alkene is E. German में इसको कहते हैं antigen, which means opposite sides. Then we come to cycloalkenes, slide number 34. In naming cycloalkenes, the carbon atoms of the ring double bond are numbered 1 and 2, always in the direction that gives the substituents and counted first the smaller number. अब अगर आप इस diagram को देखें, so these two carbons are bearing the double bond. So हमने यहाँ से start करना है. We have to take start. This is carbon C1, C2 and C3. अगर हम इसको जो है वो ऐसे चलते हैं, this is carbon number 1, 2, 3, 4, 5. So यही C1 और C2 में ही double bond है. Okay? अब C1 और C2, either आप इसको C1 कह सकते हैं और इसको C2 कह सकते हैं, डिपेंडिंग कि आपने सब्स्टिट्यूट जो है उसको स्मॉलर नंबर देना है. अब हम इसको we name as C1 and C2 because if I go in clockwise direction, so these two substituents they are present on carbon number 3. अगर तो मैं इनकी डायरेक्शंस जो हैं वो ये रखती हूँ 1 and 2, so I'll go anti-clockwise and the carbon 6 is bearing these. This is 1, 2, 3, these two methyl groups. So you have to take care about this thing. Next we go to IUPAC naming system. अब आपको I'll give you a very brief rules of double and triple bonds. तो जो आपको ये मैं बोल रही हूँ, it's for the triple bond also. So when I go to the course content alkynes, so there मैं IUPAC system को दोबारा explain नहीं करूँगी. एक तो सबसे बड़ी बात ये है कि I have given this additional source, खान अकेडमी की है, इसको आपने मतलब क्लिक करना है और इस लेसन को you have to carefully listen and practice yourself. तो रूल्स में हमारा जो सबसे पहली चीज होती है रूल्स के अंदर, उसमें यही होता है कि जो एल्कीन्स जो हैं they are named by identifying the longest chain that contains double and triple bonds. So this is the main thing, and this chain is then numbered to minimize the numbers assigned to the double and triple bonds. और suffix इसमें जो है always ene for the alkenes and ine for the triple bond and ene for the double bond. एक तो ये हो गया. सबसे पहले तो हमारा जो वर्क होता है to identify the location, to locate the double and triple bonds. सेकेंड में हम क्या करते हैं कि सबसे पहले हम चलते हैं to identify the longest chain which contains both the carbons of the double or triple bond. इसको ये जो आपकी this is called the carbon backbone, इसको हम नंबरिंग करते हैं from the end that give the lowest position to double and triple bond. So ये हमारा एक थीम होती है, एक मेथड होता है इसको आइडेंटिफाई करने. उसके बाद हमें पता है कि हमारे पास सब्स्टिट्यूएंट्स भी होते हैं. ओके, सो सब्स्टिट्यूएंट्स को हाउ वी कैन लोकेट द सब्स्टिट्यूएंट्स. सो आपको पता है कि सब्स्टिट्यूएंट्स के जो नाम होते हैं दे आर एडेड टू द नेम एज ए प्रीफिक्सेस, और ये प्रीफिक्सेस लॉन्गेस्ट चेन के साथ होते हैं. वी नो रोटेशन इज रिस्ट्रिक्टेड अराउंड द डबल बॉन्ड एंड ट्रिपल बॉन्ड, सो प्रीफिक्सेस कैन बी एडेड टू डिफरेंशिएट स्टीरियोआइसोमर्स, और वो प्रीफिक्सेस आते हैं आपके वेरी कॉमन टू सिस और ट्रांस. तो इन्हें हम यूज करते हैं टू टेल यू दैट आइदर द structure is cis or the trans. उसके बाद है कि whether higher priority substituents are located on the same side or the opposite side. ठीक है, तो ये देखने के लिए हम cis और trans जो है सिस्टम यूज करते हैं. अगर तो हमारे जो tri substituted हैं या tetra substituted हैं, then we go for the E and Z system. If your compound is now cyclic, this information is noted by adding cyclo prefix. हम cyclo word add कर देते हैं. इसके बाद हमारी next चीज आती है कि हमने positioning करनी है double bond की और triple bond की. Now, double and triple bond is indicated using the position of the carbon in the bond with the lower backbone number and suffix. हमने सबसे lowest position लेनी है, okay? इसको डबल बॉन्ड को और ट्रिपल बॉन्ड को, और जो कंपाउंड्स हैं उनकी जो साउंड है वो चेंज होती है. इफ डबल बॉन्ड इज प्रेजेंट तो हम इन करते हैं, और अगर ट्रिपल बॉन्ड प्रेजेंट है तो हम. And remember that for the cycloalkanes, the carbons in the double bond are numbered as position 1 and 2 always. So this is all about the IUPAC system. Then we go to slide number 36, which is giving you the terminologies dienes, trienes, and polyenes. Dienes means that two double bonds in the same structure. Trienes means three double bonds, and polyenes means that there are multiple double bonds are present. So हम करते हैं, अगर डाइन्स हैं तो हम फिर डाइन वर्ड ऐड करते हैं, अगर थ्री डबल बॉन्ड्स हैं तो ट्राइन हम वर्ड यूज करते हैं. So those alkenes that contain several double bonds are also referred to more generally as polyenes. Greek में poly का मतलब होता है many. अब इसमें आपके सामने यहाँ पर मैंने कुछ एग्जांपल्स दी हुई हैं, लिख दी हैं मैंने, और मैं इसको आपको एक्टिविटी भी भेज दूंगी आपको, so that you can work. तो ये आपकी असेसमेंट भी हो सकती है इसमें. आप you can go for it. Nomenclature of alkenes, इनके आप स्ट्रक्चर्स लिखें, मैं इसकी अपलोड कर दूंगी आपकी असाइनमेंट भी. नेक्स्ट स्लाइड में आ जाता है फिजिकल प्रॉपर्टीज. तो ऑल द एल्कीन्स दे आर insoluble in water, soluble in non-polar solvent. फिजिकल प्रॉपर्टीज जो हैं they are very similar to alkanes. 1 to 4 कार्बन एटम्स अगर हैं तो ये गैसेस हैं आपकी एल्कीन्स. 5 to 17 कार्बन है तो लिक्विड्स हैं. अबव ऑल हैं तो ये सॉलिड्स हैं आपकी. नेक्स्ट टॉपिक इज द केमिकल प्रॉपर्टीज ऑफ एल्कीन्स. तो इसको हम इंशाल्लाह फिर इसको चेक करेंगे कि ये कब करनी है.